Hey guys. Alright, so now we're going to do measures of variation. Alright, here's what variation. Should I have this totally ready? Oh, duh. Alright, variation is just like, I don't want to give you a circular definition, like how much it varies, or how much the data differs from itself, or maybe how much that data is different from another set of data. And there's three main ways that they study variation and that we analyze it. You can print this if you want. Do it with me. All right, so first let's look at a set of data, and then we'll discover why we need these different kinds of variations. All right, so this lab's testing two different types of outdoor paint to see how long it's going to last, and they're doing 6 different gallons of each kind. So brand A, those are the 6. Brand B, those are the 6, and that's how long, how many months that paint lasted before it faded. And so like brand A, first one lasted 10 months, the second one lasted 60 months. Brand B, the first one lasted 35 months, the second one lasted 45 months. All right, so we see these two data sets, right, and we want we want to find the mean. And so the mean is you add them all up and divide by however many there are. And so I'm going to add 10 plus 60 plus 50 plus 30 40 plus 20. And I get 210. And there's 6 of them. So I'm going to divide by 6. And I get 35 months. All right, so this paint for brand A, on average, a gallon, well, and you put it like on your wall or whatever, or outside on your, I don't know, whatever you're going to paint outside. And it lasts 35 months. All right, let's do brand B. 35 plus 45, 30, 35, 40, 20. It also lasts 210, but there's 6 of them. And then when I divide by 6, I get 35 months. All right, so both their means are 35. And so we need to be able to mathematically tell some more about this data. You know, which brand is better? And so we're going to look at its type of variations to see. All right, so I want to tell you what those are first. So we have, so mean, it implies that it's equal, like those two paints were equal, but when we look at that data, it doesn't look equal. Like these numbers are spread out, these numbers are really close. All right, and so there's 3 ways. You can do range, you can do variance, and you can do standard deviation. So range is high number minus low number, okay, and it's really important. It can be skewed if there's an outlier. And since it can be skewed, that's why we use the other 2, which is variance and standard deviation. Okay, and so variance and standard deviation is kind of a long process if you don't have some, if you're doing it by hand. And so there's a thing called the range rule of thumb, and it approximates the standard deviation. You just take the range and divide by 4. All right, so we're here. Okay, you're not going to panic when you see these formulas. I'm totally going to break them down for you. All right, so variance. Let's notice a few things. All right, so here is variance. Okay, notice we have that 1 over n, and in standard deviation we have 1 over n. And we have the summation. Summations means you add it up. We have xi, xi. We have the minus sign, then we have x bar. Remember, that's the mean. X bar parentheses, and then we have squared. That's variation. I mean variance, which is different than variation. It's a type of variation. And then for standard deviation, you just take variance and you take the square root. Standard deviation is just the square root of variance. It's just one extra step. All right, and so you see that correlation. All right, and then notice between population, right, we have divided by n. Now let's look at sample, how these guys differ between population and sample. We have divided by n minus 1. All right, so the sample you're going to divide by n minus 1. For the population, you're going to divide by n. Otherwise, it's the exact same formula. And I prefer a step thing versus here's this crazy formula. And so I'm going to show you that. It's going to ease your pain. I also want to show you that colors. All right, that variance is sigma squared. Okay, that symbol right there is called sigma. Okay, and then standard, so it's this guy, sigma, then the squared. All right, for variance. Okay, if you're doing the sample, it's just the S squared. Okay, so S squared. All right, for standard deviation, it's just sigma. So standard deviation is sigma, like a O with a line. It's a Greek letter. All right, other symbols that we learned were in. A is sample size, like how many things in your data set. X bar, that's mean. All right, so you know some of this. We're just going to put it all together, and it's not going to be as scary. All right, so if you want to do it by hand, if you're a step person, there's some steps. What I do is I make a chart. I count, so I put numbers here. So step 1, I count how many things there are. That's our sample size. And then I write those numbers down. And then I find the mean of those numbers. Then I take the mean, okay, mu, that's that U thingy, drunk cow, or you can call it X bar. And so I take whatever that number is and I subtract from the mean. Whatever that number is and I subtract the mean. Whatever that number is and I subtract the mean. Whatever that number is and I subtract the mean. And I gotta throw all my numbers this way. Then I take this number and I just square it. So be careful. Like if your number is -3 and you square it, that's really +9. So I just take this number and I square it. Just take this number and I square it. I just take this number and I square it. This number and I square it. Just take this number and I square it. If you're on our formula, that's what we do right there. All right, then I add all of those up, all those squares, and that's my sum. All right, so if you're following the formula, that's that piece. All right, then I take the sum and I divide by however many there are. That was my n. And so that's variance. I don't really know. I need more than 4 colors. All right, then I take the square root of whatever's right here. Okay, variance, the symbol is sigma squared. Standard deviation, the symbol is sigma. Right, and then I just take the square root of whatever was right there. Okay, it's long, no doubt. Okay, but let's do it. Here we are. So we're back to our 8. And I filled out the chart. There's 6 of them. That color in blue. Okay, over here. So the mean we found was 35 for the problem we did just a couple of minutes ago. All right, then I'm going to do 10 minus 35, so it's negative 25. 60 minus 35, positive 25. 50 minus 35, positive 15. 30 minus 25, negative 5. You can type this in your calculator, no worries. 40 minus 35, 5. 20 minus 35, negative 15. All right, then I'm going to take each of those numbers, negative 25, and I'm going to square it. There's my beautiful self. All right, so I want to do, I'm going to do that number squared. So it will tell me 625. If you just do negative 25 squared, there we go, it's going to not do it correctly. It's going to do negative 25 times 25, and that's not what you want. A negative times a negative is a positive. All right, so we get 625. 25 squared is 625. 15 squared, we're going to do 15 times 15, 225. Negative 5 squared is negative 5 times negative 5. 5 times 5, and this is 225. All right, I'm going to take these numbers, and I'm going to add them. 625 plus 625 plus 225 plus 25 plus 25, 225. And I get 1750. All right, then I'm going to take 1750 and divide by 6. That's how many there are. I get 291.667. Everything was a whole number, so we're just going to go to tenths. Then I'm going to take the square root. 291.7, the square root. Okay. And so I get 17.1. 17.1. And so this is my variance, my sigma squared, and that's my standard deviation, 17.1. All right, let's do the other guy. All right, 35 minus 35, 45 minus 35, 30 minus 35, 35 minus 35, 40 minus 35, 25 minus 35. All right, then I'm going to square everything. 0, 10 squared. And I've done this a long time. You get your calculator out and do it. Negative 5 times negative 5 is 25. 0 squared. 5 times 5 is 25. Negative 10 times negative 10 is 100. All right. I'm going to add that column up. To go right there. I get 250. It's a 0. All right, then I need to divide by 6. 250 divided by 6. And so I get 41.667, so I'll just say 41.7. And then I need to take the square root of 41.7. I get 6.45. That's really 6.5. So you had to do it on the calculator. Okay, to get that square root, you're going to press second and then the x squared button. Okay, even though I use, I'll save that. All right, so we get two different standard deviations. It's a long process, but this standard deviation tells you, since it's bigger, that it's more diverse, more spread out. That standard deviation, 6.5, since it's closer together, since it's closer to 0, tells you the data is closer to the mean, is more condensed. All right, I'm going to finish this lesson in the next video.